Hello there. Today we're going to be talking about converting from a standard form quadratic equation into its vertex form. Vertex form, of course, can be found here on the screen. It is any quadratic equation fitting the form y equals a times the quantity x minus h squared plus k. Now, for any quadratic equation fitting the vertex form, the vertex of the parabola is located at the point h, k, where h in the point is opposite in value from h in the equation. We have an example equation here, y equals 18 times the quantity x plus 3 squared plus 7. The vertex is located at negative 3, 7. Now, you will no doubt notice that the 3 here and the 3 here are opposite in value. This comes down to the fact that in the vertex form, the general vertex form, we have x minus h. Now, you needn't worry about this right now, as long as you always remember that if you're trying to write the vertex from a vertex form equation, you must make sure that you switch the sign of the number inside the parentheses. So now we know what vertex form is and we know how to use it. The question is, how can we go from a standard form quadratic equation, that would be your ax squared plus bx plus c, into the vertex form? Well, it's quite straightforward, actually. All you have to do is complete the square. If this is a foreign-sounding concept to you, then I would advise that you watch the Auducation video called Solving by Completing the Square. There's a series of steps in there that establish how to complete the square, and then some extra steps on how to use it to solve an equation. But take a look at the example problems that we have here before you go over there, because it's quite straightforward, really. So, without further ado, why don't we take a look at our first problem here. We are asked to convert from standard quadratic form into vertex form, and then to state the coordinates of the vertex. We do this by first completing the square. And we begin that process by taking a look at the linear coefficient, in this case 8. We take that number and we divide it by 2. 8 divided by 2, of course, is equal to 4. We take that number and square it. 4 squared is equal to 16. And then to proceed, we must add and then subtract in that order 16 immediately after the 8x. It must be in that order, and it must be immediately after the linear term, because otherwise we're not going to produce our perfect square trinomial, and, well, that's kind of the point of the whole process. Here we're going to group our perfect square trinomial together so we can factor it a little bit more easily, and then everything else stays the same. Our perfect square trinomial will factor down into x plus 4 squared, and negative 16 and negative 7 together makes negative 23. This, my friends, is our final equation, y equals x plus 4 squared minus 23. To find the coordinates of our vertex, we are going to look at the two numbers left in the equation. The x value is the opposite to the number inside the parentheses with x, so we have negative 4, and then the y value of the vertex is the number outside of the parentheses, exactly as it is, negative 23. So our final and complete answer is y equals x plus 4 squared minus 23, with a vertex at negative 4, negative 23. Let us continue now on to our last example here. We have y equals x squared plus 9x plus 12, and we are asked to do the same exact thing as before. This time you'll notice when we complete the square that 9 divided by 2 is not a whole number, so we'll just leave it as a fraction here. A fraction is not going to change our steps, however. We're going to have 9 over 2 squared again. This will give us 81 over 4. And then we must add and subtract that number immediately after the linear term to produce our perfect square trinomial. This is going to give us x squared plus 9x plus 81 over 4 minus 81 over 4 plus 12. We will group our perfect square trinomial next. That would be x squared plus 9x plus 81 over 4. And then we keep the rest of our equation the same. We factor our perfect square trinomial. This becomes x plus 9 over 2 squared, and then we have to combine our two numbers out there. 12 times 4 is 48. Negative 81 plus 48 is negative 33 over 4. Not too bad. Our final equation here is y equals x plus 9 over 2 squared minus 33 fourths. Now lastly, we must also find the coordinates of the vertex. Again, our x value is going to be the opposite in value to the number in the parentheses with the x, so we write negative 9 over 2. and then the y value of the vertex is the number outside of the parentheses being added or subtracted, in this case negative 33/4. Such is our vertex. Okay, and that about does it. If you are trying to convert from a standard form equation into the vertex form equation, all you have to do is complete the square. Don't be alarmed if there are fractions, this is perfectly normal. If you are trying to find the coordinates of the vertex from the vertex form, then the x value can be found by taking the opposite of the value of the number in the parentheses with the x, and the y value is just the number that is being added to or subtracted from the parentheses exactly. This is a fairly straightforward skill that, of course, will get better with practice and time. So, watch this video again, do lots of practice if you have to, and overall, good luck. Thank you for coming. I will see you next time.